Time. It's the most familiar stranger. We experience it every second, yet its true nature remains elusive. We feel its forward march, from the cradle to the grave. But what if this perception is an illusion? What if the future, much like the past, already exists? This mind-bending idea challenges our fundamental understanding of the cosmos and our place within it. The very idea that the future might be pre-written, like a film reel waiting to be played, is unsettling. It throws our notions of free will and choice into question. But before we delve into these implications, let's explore the scientific theories that underpin this fascinating paradox. We often imagine time as a river, flowing steadily from the past through the present and into the future. This metaphor is deeply ingrained in our understanding of how events unfold in our lives. Events unfold in a linear sequence, like leaves carried by the current. Each moment follows the next in an orderly fashion, creating a continuous stream of experiences. The past is fixed and immutable, the present fleeting, and the future yet to be determined. This linear progression gives us a sense of direction and purpose as we move forward through the river of time. This intuitive understanding, however, is challenged by modern physics. The simple, linear flow of time that we take for granted is not as straightforward as it seems. Einstein's theory of relativity, a cornerstone of modern science, paints a very different picture. It revolutionized our understanding of time and space, showing that they are interconnected and not absolute. It suggests that time is not absolute, but relative, dependent on the observer's frame of reference. This means that time can flow at different rates for different observers, depending on their relative motion and gravitational fields. Imagine two observers, one stationary and one traveling at high speed. According to relativity, their experiences of time would not be the same. Einstein's theory predicts that they would experience time differently. The faster an observer moves, the slower their clock ticks relative to a stationary observer. The faster observer would age slower relative to the stationary one. This effect, known as time dilation, becomes more pronounced as the speed of the moving observer approaches the speed of light. This phenomenon, known as time dilation, has been experimentally verified, demonstrating that time is not the rigid, universal constant we once thought it was. Experiments with atomic clocks on fast-moving aircraft and satellites have confirmed that time indeed flows differently depending on the observer's speed and gravitational field. In the vast expanse of space, where astronauts travel at incredible speeds and experience different gravitational forces, time dilation becomes a significant factor. Their clocks tick slightly slower compared to those on Earth. As we continue to explore the universe and develop new technologies, our understanding of time will undoubtedly evolve. The river of time may not be as straightforward as we once believed, but it remains a fascinating journey that shapes our existence. Just like a river that eventually merges with the vast ocean, our journey through time is filled with endless possibilities and mysteries waiting to be discovered. The more we learn, the more we realize how much there is yet to understand about the nature of time itself. Einstein's theories led to the development of the block universe concept. This revolutionary idea has changed the way we perceive time and space, offering a new perspective on the very fabric of our reality. This idea proposes that the universe is not a dynamic entity evolving in time, but rather a static, four-dimensional block. In this block, time is just another dimension, much like the three spatial dimensions we are familiar with. All moments in time, past, present, and future, exist simultaneously within this block, just as all points in space exist simultaneously. Imagine looking up at the night sky and seeing not just stars, but moments in time, each twinkling point representing a different event in the vast timeline of the universe. Think of a frozen lake. The surface of this lake can be seen as a snapshot of a single moment in time, frozen and unchanging. The surface represents a moment in time. Just as you can point to any spot on the lake's surface, you can pinpoint any moment in time within the block universe. Every point on the surface exists simultaneously. This means that every moment in time, from the distant past to the far future, is equally real and present within the block universe. Now, imagine the lake's depth representing the entirety of time. As you drill deeper, you uncover layers that represent different moments in history, each one preserved in the frozen expanse. Every event, from the Big Bang to the end of the universe, exists at some point within this frozen lake of space-time. the birth of stars, the formation of galaxies, and even the rise of human civilization are all embedded within this timeless structure. In this view, the future is no more or less real than the past. Both are simply different layers within the same frozen lake, waiting to be explored and understood. It's just over there in space-time, waiting for us to reach it. The journey through this block universe is not about moving forward in time, but rather navigating through the layers of existence that are already there. This concept, while mind-boggling, is consistent with our current understanding of physics. It challenges us to rethink our perception of time and space, and to embrace a new way of seeing the universe as a vast, interconnected whole. Section 4. Paradoxes: Can we change the past? The block universe model raises some perplexing questions, particularly about time travel. This model suggests that the past, present, and future all coexist simultaneously. In other words, every moment in time is equally real and unchanging. This concept can be quite mind-bending, as it implies that the future is already set in stone, just waiting for us to experience it. If the future already exists, can we travel to it? This question has fascinated scientists, philosophers, and writers for centuries. The idea of moving through time, much like we move through space, opens up a realm of possibilities and challenges our understanding of reality. And if so, can we change it? If we could travel to the future, would we be able to alter events that have yet to happen? Or would we be mere observers, unable to influence the course of history? This is where we encounter the infamous paradoxes of time travel. These paradoxes highlight the logical and philosophical challenges that arise when we consider the possibility of altering the past or future. The most famous of these is the grandfather paradox. This paradox poses a significant challenge to the concept of changing the past. Imagine you travel back in time and accidentally kill your grandfather before your parent is even born. This action creates a contradiction that is difficult to resolve. If your grandfather died, you wouldn't exist to travel back in time. This creates a loop of impossibility that defies our understanding of cause and effect. If your grandfather died, you wouldn't exist to travel back in time. But if you don't exist, you couldn't have killed your grandfather. This paradox creates a logical inconsistency that challenges our understanding of time and causality. But if you don't exist, you couldn't have killed your grandfather. This creates a loop of impossibility that defies our understanding of cause and effect. The grandfather paradox is just one example of the many challenges that arise when we consider the possibility of changing the past. This paradox highlights the logical inconsistencies that arise when we try to alter the past. It forces us to question the very nature of time and our ability to influence it. While the grandfather paradox seems to rule out changing the past, it doesn't necessarily negate the possibility of time travel itself. Some theories suggest that time travel might be possible, but with certain constraints that prevent us from altering history. Some physicists propose that time travel might be possible, but with constraints. One such theory is the idea of parallel universes or alternate timelines. In this scenario, traveling back in time might create a new, divergent timeline, leaving the original timeline unchanged. We might be able to visit the past but not interact with it like a spectator watching a film. This concept, known as the Novikov self-consistency principle, suggests that any actions taken by a time traveler would be part of history all along, ensuring that the timeline remains consistent and free of paradoxes. Ultimately, the question of whether we can change the past remains a topic of intense debate and speculation. While current scientific understanding suggests that altering the past may be impossible, the mysteries of time continue to captivate our imagination and drive our quest for knowledge. As we continue to explore the nature of time and the possibilities of time travel, we may one day uncover new insights that challenge our current understanding. Until then, the paradoxes of time travel serve as a reminder of the complexities and wonders of the universe. The journey to understand time is far from over, and each new discovery brings us one step closer to unraveling the secrets of the past, present, and future. Section 5. Many worlds, a universe of possibilities. Another intriguing concept that arises from quantum mechanics is the many worlds interpretation. This theory suggests that every time a quantum measurement is made, the universe splits into multiple parallel universes, each representing a different outcome. Imagine flipping a coin. In one universe it lands on heads, in another, it lands on tails. Each universe continues to evolve independently, creating an unimaginably vast multiverse where every possible outcome of every event exists somewhere. If the many worlds interpretation is correct, then every possible future already exists in some parallel universe. This idea provides a different perspective on the concept of a predetermined future. Rather than a single, fixed timeline, we have a multiverse of possibilities, each representing a different path that reality could take. Section 6. Free will. Are we really in control? The idea of a predetermined future, whether in a block universe or a multiverse, has profound implications for our understanding of free will. If the future is already written, are our choices merely illusions? Are we just actors following a pre-scripted play? This question has puzzled philosophers and scientists for centuries. Some argue that free will is incompatible with a deterministic universe. If every event, including our thoughts and actions, is preordained, then we can't be truly free. Others, however, propose that free will and determinism are not mutually exclusive. They argue that even if the future is fixed, our subjective experience of making choices is still real and meaningful. Our choices, though predetermined, are still a reflection of our unique consciousness and experiences.